take it away.
Thank you very much, Aaron, and welcome everyone to this session on SQL Server and containers. A little bit about myself first. My name is Andrew Pruski. I'm a SQL Server DBA and data platform MVP, originally from Swansea, Wales, but I've been living in Dublin, Ireland for about 4 years now. My Twitter handle and my email address are up there at dbafromthecold and dbafromthecold@gmail.com. So if you have any questions after today, please feel free to ping me. I'm always willing to talk about this stuff. My blog's there, dbafromthecold.com. I've posted multiple articles about containers, some of which I'm using to base this session on, and some of which go into a little bit further information, so you're more than welcome to check that out. And whilst this session is happening, I'll actually be tweeting out links to blogs that I've posted about the relevant subjects, and you can find them all under the hashtag PowerShellVG. So today the aim of the session is, well, there's a lot of buzz about containers in the technology world, but not so much in the SQL Server world. And I find that odd because this technology has some benefits that we, as SQL Server people, simply shouldn't be ignoring. It has some drawbacks too, which we'll cover, but I'm hoping after today, you can go away and take the background knowledge commands that I've given you to evaluate this technology for yourself. So here's what we'll cover. We're going to start off with a little bit of container theory, but I don't want to really spend too much time in the slides. I actually want to get straight into showing you code. So we'll cover some basics, and then we'll get into building our first container. After we've got that, we'll then look at building a custom image from building a custom container image, and then pushing that image up to the Docker Hub. After that, we'll look at persisting data within SQL Server containers, and then very at the end, if we have some time, there's a nice little GUI called Portainer that we can use to admin our container stack. So first things first, what are containers? Now, the definition there is from the Docker website, and it says that a container is an environment that contains all the necessary binaries and libraries required by a piece of software so that it can run in the same manner regardless of its environment. Basically, a container is an isolated place where an application can run without it affecting the rest of the system or the rest of the system affecting it. In practice, they are lightweight objects specifically tuned to perform one function, say, running an application such as SQL Server. They are quick and easy to deploy, easy to customize, and easy to share. So just a little bit of terminology for you here. The first one there, the container host. Very simply, this is the machine that we run our containers on. And we interact with our containers through the container engine, which is just a service that we can send a variety of commands to, such as how many containers do I have and what state are they in. Then we have the container registry, which is simply a repository to store our container images. Now, container images were explained to me as the installed state of an application in a reusable format. They're baselines that we can use to build containers from, and every single container built from an image will be a carbon copy of all the other containers built from that image. So those are the fundamentals. Very quickly, let's see how they compare to virtual machines. On the left of the screen there, we have the virtual machine infrastructure that we've all come to know and love over the years, with our infrastructure at the bottom, and then our operating system and hypervisor on top of that. On top of all of that, we then have our virtual machines with our full-blown guest OS and our applications, and then binaries and libraries supporting them. Moving over to the container side of things, things are a little bit different. We still have our infrastructure, and then we have our operating system, and on top of that, we have the container engine running as a service generally. On top of all of that, we then have our containers, and the containers only have the necessary binaries and libraries required by the applications within them. And that is the key difference. Containers do not have a full-blown guest OS, and as such, their footprint is significantly less than virtual machines. You can run a lot more containers on a host than you can virtual machines without oversubscription. So why do we want to implement containers? Well, I've already said the containers are very simple and fast to set up. We can have a new instance of SQL Server running in seconds. I've already said they have a low footprint compared to VMs. Back in a previous company, I was running anywhere between 40 and 50 containers on a host, all running instances of SQL Server, using out 50 gig of memory, 200 gig of disk space. Far less, I would say, than if I had 40 or 50 VMs running the same. We also have the ability to customize images that we pull down from the Docker Hub. So we don't have to just use the generic images that Microsoft give us. We can take those images and change them so that when we run a container, we have an instance of SQL Server that's not only configured to how we want it to be, but we have our development databases in there ready to go as well. Very, very powerful when it comes to building development environments. With Docker, we have access to the Docker repository, which has hundreds, if not thousands, if not hundreds of thousands of images available. Okay, for us as SQL Server people, we may be only interested in a few of those images, the SQL Server images. But the fact that the hub is there means not only can we pull images down from the hub, we can push images back up to it. Very, very useful when it comes to sharing with remote teams. Of course, there are some downsides, and the first one there is a big one: no Windows authentication. However, I really would watch this space. And if you do need Windows authentication, there is also another system called Windocs that allows for containers to run and enables Windows authentication. The next point there, only supported on Windows Server 2016 or Windows 10 Anniversary Edition. So if you're running an older system, that might be a blocker for you. Again, you can use Windocs, which is a custom port of Docker, which allows containers to run on an earlier version of Windows Server. So 2008 and upwards, both cases. The official SQL Server images are from Microsoft are for 2016, 2017 only, but at the end of this demo, I will show you some links to get earlier images. So if you want to run SQL Server 2012 or 2014 in a container, you can. And the second from last point there, SQL images aren't the smallest. These are for Windows images. The Windows images do vary anywhere from between 13 gig to 15 gig. So if you don't have a very fast internet connection when you're pulling the image down from the hub, that can take some time. However, if you're using the Linux images, they are about 1.5 gig, so they are a lot smaller. And the last point there, suitability for production. If you think about the pros that I've said, simple and fast to set up, easy to customize, are these really applicable for a production environment? Okay, maybe in a DR scenario when I need to get an instance of SQL Server up and running really, really quickly. Okay, that could be a point, but I really am on the fence as whether or not this technology is suitable for production. But as the technology is evolving, it is becoming more mature, and maybe in the future we will see, hey, yes, we can run this stuff in production. Okay. So I'm going to jump after this slide into the demos, and I'm going to run all of this stuff on my Windows 10 desktop using Visual Studio Code. And if you want to get Docker for Windows 10, you need to be running the Windows 10 Anniversary Edition and Pro or Enterprise Edition so that you can use the hypervisor enabled and the containers feature enabled. And then to install Docker, it's really, really simple. Just download the MSI from the Docker store from the link there, click next, 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 and you are good to go. So that's enough slides. Let's go and crack in straight into running some demos. So I have my Windows 10 environment here, and I have Docker running. I can check that by looking down here and seeing that I have my Docker icon. What's really cool about Windows, for Docker for Windows, is that I can switch between Windows and Linux containers. So at the moment, I am running Linux containers because I really like this feature, because I can run SQL on Linux in a container on my Windows 10 desktop and stay in my familiar environment. Because if you're like me and your Linux skills aren't great, this is a really good way of getting started with SQL on Linux. And the way this works is you need to have a hypervisor feature enabled, because Docker will spin up a little VM here, and that is where you run your containers. And that is how you get Linux containers running on your Windows 10 desktop. A little word of caution when you do this: when you first set this up, you will need to go into the settings down here, go to advanced, and increase the memory. The initial memory is for, I think it's 2 gig, and SQL needs a little bit more to actually run in a container. So just change the memory there, hit apply. Don't change it in the actual Hyper-V manager here, because the changes won't persist. But there we are, Docker is running. I'm going to now jump into Visual Studio Code, and I'm going to use some modules to interact with my SQL instances in my container. So I'm going to use the credential manager, DBA tools, and if you don't know what DBA tools is, it is a open source community driven module that has, I think at last count, over 300 commandlets to interact with SQL Server. And I'm also going to use the standard SQL Server module as well. So let's just make sure I've got those running. And then I'm good. And the first thing I'm going to do is set some credentials so I can connect to my SQL instances. Remember, there's no Windows authentication. I don't really want to be typing out a username and password each time. So I'm going to double check. I'm going to create a credential called SQL Docker, username SA, and a password. I'm going to persist that on my local machine. Excellent. Okay, let's just double check that's there. Cracking. Okay. So the first thing I'm going to do is verify that my service is running and all looks good. Service is running. And now I can send my first Docker command. And I always like to keep this very simple. So I'm just going to say, hey, Docker, what version are you running at? If we have a look, if I bring this up slightly, actually, there we go. So I have my client running on Windows and my server running on Linux. So I have Linux as my container host, which I think is kind of cool, working in my familiar VS Code environment using PowerShell. So now I know that Docker is up and running and is responding to commands. I can now start building images. And the first thing I need to do is find an image that I want to use to build containers from. So I want to search the Docker hub and pull an image down. So the first thing I do is say, hey, Docker, search an image for me called Microsoft/MS SQL. Show me all the SQL Server images available on the Docker hub. So I have an absolute load here. So the one I'm interested in is the Microsoft SQL Server Linux edition, but there are other ones here. There is the Express Windows edition and the Windows Developer edition as well. But I'm going to go with the Linux edition because I'm running Linux containers. So I'm going to pull that down to my local repository. I'm going to do that via the Docker pull command. So hit execute. And I've cheated slightly because I didn't want to waste any time pulling this image down. So that is already in my local repository. And I can verify that by running the Docker images command. There it is. And the size there of 1.4 gig. Okay. So now that I have that image in my repository, I can run a container. So bear with me here. What we're going to do is we're going to say Docker run -d, run it in detached mode, run this container in the background so I can continue using this environment, -p, now mapping port 15111 on my host to port 1433 within my container, the default port that SQL listens on. And all this is doing is saying that any connection that hits my host on port 15111 will automatically be mapped to port 1433 within my container, and I can connect to my instance of SQL Server. Then I'm going to specify an SA password, give my container a name, and specify the image that I'm building, and I pressed the wrong button. Awesome. Where are we? There we go. And then just specifying the image that I built my container from. So if we run that, hit execute. That was pretty quick, so let's have a look. Now I need to verify that my container is running, and I can do that via the Docker ps command. Okay. So by default, Docker ps shows all containers running on my host. If something's gone wrong, I can run Docker ps-a, and that will show the status of all my containers on my host, whether they're running or not. So here, execute. And my container has a status of exited. Okay. So what I can do now is have a look at the logs of that container to see where the error is. So if I just clear that out, jump in, say Docker logs on my container name. The SQL Server end user license agreement must be accepted before SQL Server can start. Okay, so what I'm going to do now is remove my container, and I'm going to say Docker remove RM my container name. Get rid of that. And this time, let's run the container accepting the end user license agreement. Hit execute. Excellent. And let's verify that that's running. Brilliant. My container has a status of up. Okay. Let's have a look at the logs. And that to me looks like SQL is starting up and everything looks A-OK. So let's do some stuff. Let's have a look and check the version of SQL in my container. I'm going to use a DBA tools module here called Connect DBA Instance. and then pull out a load of information. Oh, that doesn't look good. What's happened there? Let's try again. Is my container still running?
Are you using that port? Or did I misunderstand it?
Yep, I am missing my port. It doesn't like my credential for some reason. Let's have a look. Oh, let's go back up. One more time. No, okay, doesn't like my CPR. Let's try. Is my credential there? Oh, hello. My credential isn't there. Let's try that again, shall we? Haha, okay. So let's have a look at what we've got here. So we have, if we scroll up, a whole bunch of information. I have Development Edition running on Ubuntu host platform Linux. So I am running SQL Server on Linux from my Windows 10 desktop, interacting with DBA tools and PowerShell, which I think is pretty cool. And we can do other stuff. Let's actually have a look within the container. So using docker exec-it test container and then running a bash command, I can actually remote into my container. A word of caution here, there's a little bug. The first key I press won't actually register. I have to press something twice. There we go. And it'll catch you out every single time. And I can actually have a look within my container. And there are my system databases running within my container. So let's come out of there. Jump back up. Okay, so I have an empty instance of SQL. Let's have a look at copying a backup file into that container using the backup cp command. So I'm going to say specifying a file path, docker cp, copy that file into my test container and to that location that we just had a look at. So I'm going to copy it into the location with the system DBs. Okay. Let's check that it's there. Jumping back in. Oh. Let's try that again. And there's my database file. Cool. Okay. Let's use another DBA tools command and let's restore that database into the container. Hit execute. Wait for it. Come on now. Okay. That's not great. Okay, let's have a look. Let's try one more time. If it doesn't work, we'll move on. There we go. Has that worked? Restore complete. True. Excellent. Let's verify that it's there. And we're going to connect in again and just run how the database is. And there is my database running in my SQL instance in my container. Cool. So let's run a couple more containers, doing exactly the same thing. One thing I will do, change that. And 2, excellent. Let's have a look at all my containers. One thing I will do is just bring this back, clear that. Let's have a look again. Make the screen a little bit more easy to read. Status, they're all there, up, up. Let's do that. It doesn't want to play nice. Okay, cool. So we have our containers, we have them up and running, 1, 2, and 3. Let's have a look at some system stats. Let's not actually, if it's going to do that. Let's see if we can get it a little bit clearer. There we go, that's a lot better. Okay, so we have all of our images, we have all of our containers, and we have any volumes that are on the system as well. That's cool. One thing I will mention is we can have a look at this here. We can see our container image, its unique size, and the number of containers running. So we can pull out quite a lot of information from here just from running docker system df -- verbose. So we can also have a look at individual stats on our containers. So we can see CPU usage, memory usage, network I/O, and disk I/O as well. And not only that, we can also limit the resources available to our containers. So we can limit the number of CPUs and the memory available as well. So let's do that. Check our containers running. Excellent. And check the stats. So we can see the last container there, its memory use with a limit, and then all the other stats of it. Cool. Okay, let's do a quick cleanup. So that's great. I've spun up instances of SQL Server running containers in a very, very short period of time, but they are empty instances of SQL. Okay, I've used PowerShell and I've started restoring databases in, which is great, but it's kind of missing the point of containers. What we can do now is take the image that we pulled down from the Docker Hub and change it and configure it so that we can have an instance of SQL that's not only configured to how we want it, our dev databases are there ready to go as well. Let's make sure my cred is there. Let's double check. Excellent. Okay. So here's my image, and I'm going to, here are my images, and I'm going to take this image and customize it to how I want it to do. And the way I do that is via a Docker file. And all a Docker file is a file on the host that contains a bunch of commands that when we run a certain Docker command, it will execute every single command there, in turn building us our custom image. So all I'm doing here is saying from Microsoft SQL Server Linux latest, the image will be pulled down, making a directory within my container, copying a couple of database files into that directory. And because there's no file path there, we then need to have those database files in the same location as our Docker file. And because I'm tired of typing out every single time, I'm going to bake the SA password and accepting the end user license agreement into my image. And then finally, I'm going to run a little command here, and what that's going to do is create a database in my SQL instance from those database files that I copied in, so that when I spin up my container, my database is there ready to go. So I need to build that image, and I do that via the Docker build command. So I'm specifying a file path here to the location of my Docker file, saying Docker, build me a custom image, -t, tag it with a name, file path, and then my Docker file 1. Just clear that out and hit execute. And we can see Docker stepping through each one of these containers, building me my custom image. Okay, I have a warning down there saying that I've built from Windows into a non-Windows host, and that the files and directories will have a little bit open permissions on them. So I need to go and sort that out if I was doing this for a different environment. But as it's a demo, let's continue. Let's jump in and have a look. And there's my new image, a little bit bigger than the Linux image because I've copied a couple of files in. But now let's run a container from that custom image. And so I'm saying Docker run -d -p map import 515555. Oh, and by the way, I'm picking these ports out of thin air. All I'm doing is picking a port that I know is not going to be used on the host. Giving my container a name, and then specify my new image. Note I don't have to specify an SA password, and I don't have to specify, except in the end user license agreement, they are baked into my image. Let's have a look. Okay, being a little bit eager, I have a 10-second health check on that, so let's give it a few more seconds. Looking good. And let's check my databases in my container. Wonder if that credit, oh, has happened there. That's very different. That's new. Okay, let's. Apologies. Just having a quick look at what's happened there. One 5111 with my credentials. One more time. Okay. For some reason, DBA Tools has decided not to play nice with me here. That is exactly the same.
Sorry, I was slurping my water when you did that. What is it, not producing?
Yeah, it's just decided to give me a whole bunch of random information instead of giving me the databases in my container.
Aha. Can you?
Which is interesting.
Can you?
Which is interesting.
Oh, so it's doing the unformatted, is what it's doing?
It does look like it, doesn't it? There we are. My containers there. Very interesting.
Okay, so can you try just the standard command in the SQL Server module for get-SQL database?
I'll tell you what I can do. Yeah. If it's going to play not nice, let's spin up Management Studio and jump in there.
Sure. Which, by the way, everyone who's on today's meeting, there's a fresh version 17.6 that came out this morning, aka.ms/SSMS to download to the latest version.
Let's have a, while that's loading up, container is there. It is up and running. Okay, awesome. There we go. Okay, so I'm on my host. I'm going to type in local host 15111 SA and my password, and I'm in. Yay, and my database is there. So, okay, I'm not too sure what happened with DBA Tools there. It was giving me the unformatted version from one demo to another, but I have spun up a container from my customized image, and my database is there ready to go. Okay, so let's build another custom image from a different Docker file. Let's live a little bit dangerously, shall we? Let's spin up this one. I'm going to do a few different things in here. I'm still going to start off with building from the Microsoft image, running a command with var SQL Server, again copying a database file, and specifying the SA password and accepting the end user license agreement. But then I'm also going to set this version of SQL Server to Enterprise, set a few default directories, change the default port that SQL's listening on, and then attach that database. So let's run that. Excellent, I've got the same warning again, but I'm not going to care about that. Let's make sure the image is there. And let's run another container from that second image that I've built. Make sure that's running. Give it a few more seconds. There's a 10-second delay on that. And the reason there's a 10-second delay on that is I've put that in there so that SQL has time to spin up within the container before I start trying to attach that database. Okay, and let's try this one more time and see what happens. Nope, doesn't like it. So let's jump into Management Studio and see if my database is there.
It actually looks like you got just fine output. Could we look at it again? It just was not formatted.
It's not formatted yet. Something's changed between what I should have done is give me a nice list of the databases in my container.
Sure, but you could just say, run that same command and pipe it to select and say just select name, and you'd get the nice list you're looking for.
As in?
Just select, yeah, the word.
Object name?
Yeah. Yeah.
Let's try that.
The dash object is always
there we go.
optional.
Boom.
Yep, there you go. So that's all. It's actually a XML formatting thing, so it's not a big deal to worry about.
No, yesterday it gave me a nice output with a load of database information in a list, and today it's given me it in that format for some reason. But okay.
Yep. No,
but there we are. We have our database that is available. So, we have our database that's been built from our custom image. So let's try another bits and bobs. Let's see if the version of SQL that's running in there. Cool. So I have the Enterprise Edition of SQL running in a container on Linux in my Windows 10 environment. So I can take an image of SQL Server from the Docker Hub, customize it to how I want it to be, and then save it as an image, and I can spin up as many containers as I want from that image. So let's do a bit of a cleanup, and we'll kill that image. Brilliant. Okay, so we're spinning up containers built from our custom image, and we're spinning containers up, we're testing against them, we're blowing them away, we're spinning them up, we're testing against them, we're blowing them away. But our company has a remote team, and they want to use this image as well. Now, you can export container images out, and you could put them on a file share or FTP site, something like that. But because we're using Docker, we have access to the Docker Hub. So we can actually push an image, not only just pull an image down from that hub, we can then push an image back up. So you need a Docker account for this, and you need to go online and register at cloud.docker.com. And I've built a test repository here. It's an empty repository, there's nothing in it. So what I'm going to do now is take that custom image that we've built, tag it with this, and push it up to the Docker Hub. So the first thing I'm going to do is make sure my credential is there. And then I'm going to log into the Docker Hub with the Docker logging command. I have my password in a file here. Just going to pipe that into the command here. Hit execute. Excellent. And we're going to take this image here and push it up to the hub. And the first thing I need to do is tag it with the remote repository name. So what I'm going to say is docker tag test image 1 db from the cold / test SQL repository Linux demo. Boom. Okay, let's have a look at the images here. Excellent. Okay, we have our test image here, but we also have another image here. Now it does look like Docker has created a new image, but actually all it's done is presented the same image with a different name, and we can see that via the image IDs here. But we've got our image tagged. We can now push it up to the hub. Nice, easy. We can say docker push dba from the cold / test SQL repository and the Linux demo. Hit execute. And this shouldn't take too long, because even though it is 1.3 gig in size, Docker is kind of smart, and it'll say, hey, actually, this is built from the Microsoft image so I can take all the bits and bobs from my Microsoft image and use that for this image. I'm only just going to push the differences up, and you can see that it's already done. And if I go back to my repository here and give it a refresh, there is my image pushed up to my hub, and it is 471 meg, which is a lot less than the 1.43 that it's reporting down here. But that means it is now available up in the hub, and that my remote team can pull that down and they can push it onto their Docker host and they can start testing against it. This is very, very useful when it comes to sharing with remote teams. Okay, I can also search for it here. If I do a DBA from the code, there is my test SQL repository. So I could do a Docker search and then pull that down like we did with the Microsoft official image right at the start of these demos. Hit execute. Brilliant. Okay. So far we have spun containers up, tested against them, blown them away, created custom image, spun them up, tested against them, blown them away. But when we blow away a container, any data that we change within that container will be lost. So we need a way of persisting data within our SQL Server containers. And there are a few ways of doing that. And the first one is to mount volumes from our container host to our containers. Make sure that's there. So first thing to do, let's create a volume on our host. I'm going to call it C SQL data. Hit execute. Excellent. And now I'm going to run a container and I'm going to map that volume on my host to a volume within my container. So this is the key difference here. I'm going to say -v volume, C SQL data, the volume I just created, and mapping that /SQL to a volume /SQL Server within my container. Hit execute. Brilliant. And let's jump in. Let's make sure it's running first. Excellent. And let's jump into that container and see if the volume is there. Well, C SQL Server. Excellent. My volume is there. Coming back out. And let's create a database within that container on that volume. So playing it safe here with invoke SQL command, hitting execute. Cool. Let's check that it's there. Boom, there is my database. Okay, cool. So let's just create some data. Let's create a test table and insert, say, 100 rows into it. Let's verify that row's there. 100 records. Okay. So now what I'm going to do is blow that container away, and I'm not going to be nice about it. I'm just going to say Docker, kill that container, and then remove it immediately. I could say Docker, stop the container, and that would shut down the container gracefully, but I don't want to do that. I'm just going to say, hey, get rid of that container immediately. Brilliant. Make sure that container is gone. No containers. But let's have a look at my volume on my host to see if my files are still there. Actually, let's just clear that out. Jump back up. Excellent. My volume is still on my host and my database files are there as well. So let's spin up another container and remap that volume. Verify that it's running. Excellent. Is my database there? Oh, hang on, that nearly got me. Actually, let's do this. Select.
You don't need the dash object.
I know, it's just me being pedantic. Visual Studio Code will tell you if you're using an alias, and it drives me a little bit nuts.
Well, for any dash object, it is not required. Jeffrey Snover said that himself. So
yeah, no, that's cool. If I do that, it'll do that to me, and it winds me up. Okay, so my database isn't there, but of course I haven't actually attached the files. So I'm just going to skip over this one. I'm going to use a DBA tools command again to mount my database into my SQL instance. That looks pretty good. Let's go back and see if my database is there. And there's my database. Cool. And so to prove that I'm not cheating, let's query that table and see if the records are still there as well. Excellent. So we have spun a container up with a volume mounted from the host, created a database on it, pushed some data into it, blown that container away and then remapped it to another container, reattached the database, and our data is still there. So let's clean that up. Okay, so that's one option. I'm going to go through one more option here, and that's, okay, some people don't like mounting volumes from the host. They want a different option. And one of those options is to use named volumes within the Docker environment itself. So first things first, let's make sure it's not there. Brilliant, okay. So first thing I need to do is create a volume within the Docker system called SQL Server. So Docker volume create, and then verify that it's been created successfully. There we go. And now, same as before, I can spin up a container with that name volume mapped. And this time I'm just saying -v SQL Server 2 / SQL Server within my container. Excellent. Make sure that's running. Cracking. And let's do the same thing again. Let's create another database on that volume. Brilliant. Excellent. So I have my database there. And now let's put some data into it. 200 records this time. Verify that that data's gone in. And same as before, let's blow that container away. And let's not be nice about it. Let's just get rid of it immediately. Cool. But my volume is still there. Let's come back here. So what I can do now, is spin up another container exactly the same as before, mounting that volume again to another volume within my container. Oh, did that work? Yes. Okay. Verify the container's running. Excellent. And doing the same as before, mounting the database using the mount DBA database DBA tools command. Excellent. We've got our success at the bottom there. Check the database. Oh, I just did it again. Oh, there we are. That's the output I was looking for as before. I have no idea why from one run of one command to one run of exactly the same command. It seems to have done that, but there we are. Keeping me on my toes. Let's query the table, make sure the data's there as well. And we have our 200 records. Excellent. Brilliant. Okay. And let's just do a little cleanup there. So those are two options to persist data when working with SQL Server and containers. We can either mount from the host, create databases on that mounted volume, or we can create a named volume within SQL itself and create databases on that volume. There is a third option, and that is data volume containers. And what we do here is we create a container, we don't run it, we just create it, and that has a series of volumes mapped to it. And then when we create another container running SQL Server, we mount the volumes from our initial data volume container into our SQL Server container. So let's have a quick look at that. First thing to do is create the data volume container. I'm going to clear my screen. And I'm going to say Docker create, not run, dash SQL data and SQL log volumes in a container called data store. And I'm just going to use a Ubuntu image because I don't need SQL Server running in this container. I just need a container to hold my data volumes. So we hit execute on that. Verify that the container is there. See, it is up, it's there, it's created, it is not running, it is just there with our volumes. So what I can do now is create a SQL Server container with a volume mapped from with the volumes mapped from that data container. So I say Docker run -d -p, we're mapping our ports, and then we say volumes from, our data store container, and then specifying the SA username and password, accepting the end user license agreement, giving it a name and the image that we're building from. Just highlight that. My bad. Let's go back to the keyboard. Hit execute. And let's verify the container's there. Cool, so I have my data store container running, created, and I have my SQL Server container up and running. So now I can create a database exactly the same as we've done in the previous two examples, but on my SQL data volume and my SQL log volume created from my data volume container. And we can make sure the database is there. Let's see if this one will work. Excellent. I've got my database F at the top there. Let's now create exactly the same. Create a test table, insert in 300 records this time so I can prove that I'm not cheating. And let's make sure that's working. And we've got our data there. We have our 300 records. Same as the previous ones. Let's not be nice about it. Let's blow the container away and remove it immediately. Cracking. But my data volume container is still there. So I can now spin up another container with the volumes mounted from that data volume container. Once again, using the DBA tools, mount DBA database. Oh. Have I been a little bit? I've been a little bit too eager, I think. Let's have another go. Excellent. Okay. Confirm that it's there. Brilliant. And then just to double check, are my records in my? Absolutely fantastic. So we have spun up a data volume container, kept it not running, but with volumes mounted to it, and then spun up a SQL Server container, mounted the volumes from that, put some data in it, blown that container away, spun up another one, and mounted the volumes from our old data volume container back in, reattached the database, and our data has been persisted. Excellent. Okay. So that are the different options for persisting data within containers. And the last, about 5 minutes left, so the last little demo I want to show you is, I know I'm talking to a lot of PowerShell people, but one thing that's really cool with working with this is we can now use containers and spin up a nice little GUI that we can hand off to people and say, look, you can manage your containers yourself. So we can be the system-wide admin, but we can set this up and give people certain access so that we don't need to manage their containers. They can spin up containers as much as they want. And the image that we're going to use for that is called Portainer. It is free. It is available on the Docker Hub. And let's make sure, I don't need that. My cred is there. And then let's have a look for the image. Now there's a whole bunch of these, but the one we're looking for is the official one, which is the Portainer. We can then pull this down. If I jump down to the bottom. Yep. I've again have already pulled this image down, so it is in my hub. And I can spin this up as a normal container. So I'm just saying Docker run -d in the background, mapping port 9000 to 9000 because that's the port it listens on. Mapping volumes var run docker sock. This is a requirement for Portainer to work. Giving it a name and specifying the image. Excellent. Let's make sure that's running. Haha. Okay, so I can now jump into this and let's do this here. Otherwise, it'll remember my load credentials. Create a password. And then hook into my local system. And I can see that I have one container, 7 volumes, 4 images, and I can manage everything through here. So I can have a look here. I can see all the images that I have available to me. I can see the containers that are running. I've only got the one at the moment. But what I can do is set up users and they can have certain access to here so they can build containers themselves. So I can manage everything through Visual Studio Code, but when my developers want to start building containers themselves, they have the option of using Visual Studio Code, and maybe I don't want to give them that access to my container host, and I want to give them access through this GUI here. So that's a different option that we have for managing our system. Okay, so that's pretty much all of the demos. I'm just going to jump back into my slides to finish off. Got a little, yep. So I did mention at the start that if you want to run an earlier version of SQL Server in a container, there are different options. You can either check out Windocs, which is an open port of the software that Docker's made available to the community, which allows for earlier versions of SQL Server to run on earlier versions of Windows Server. Or if you want to, you can have a look at the images that I've made available on the Docker Hub, which are SQL Server 2012 Dev SP4, 2014 Dev SP2, and also I've created a SQL Server on Linux image that has the agent installed, because the default one by Microsoft doesn't have the agent running. So if you want to, you can check that out as well. All the code for these demos are on my GitHub, and you can pull that down if you'd like as well. And I've got some further information for you here, just a summary of all the information that I've run on my container series at the top there. The case study that I went through there, because I'm slightly running out of time, was published on SQL Server Central, and that's just how I implemented containers in a development environment in a previous company. And there's also published an article on SQL Shack, which is how to run Docker on Windows Server Core. Because if you run it on Windows Server, it's kind of pointless having the GUI there, because all the interactions you're going to have with Docker are through the command line. So you can absolutely run all this stuff on Windows Server Core. There's just a couple of extra configuration steps, which I've detailed in a step-by-step guide there, which you can check out if you want to, of course. So that's pretty much me. Aaron, do we have any questions?
Yes, we do. We have several, and I'll try to go through them really quickly. You should be able to get to the questions panes if you want to look at them yourself. One of them was, what happens with your data once you destroy the container that is running SQL Server? That was early on in your demo, so I believe that's before you got to the mounting the volumes.
Yes.
And all that.
Unless you have a volume mounted, a name volume, or mounted from the host, or a data volume container, once that data is in your container and you blow that container away, it will be gone.
All right. Let's see. What was the link to get Docker?
Oh, it is. Where are we? Here. store.docker.com.
And then I think you may have touched on this a little bit, but I'll just read the question as it appears. Andrew, what do you need to run this on your local host?
On your Windows 10 environment, you need Windows 10 Pro or Enterprise Edition with, I think, 2016's anniversary update, because that's when the containers feature came in. So then you need to enable Hyper-V and containers, download the MSI, click next, 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 and you are good to go.
All right. And then we've got several questions about are your scripts available so that they can practice this on their own environment?
Yes, they are on my Docker Hub. If you go to GitHub and search DBA from the cold, you will see containers demos there.
Right. Sounds good. I guess that covers.
Oh, I can see a question from Shane there saying, how am I tweeting while presenting? It is called Buffer. It is awesome. It is really, really handy.
Yep. And I think that is all the questions that we have for you today. So great presentation, helped a lot. One quick question I have for you, when you were doing the restore and doing the get database, was there any reason not to use the official PowerShell Microsoft commands like restore SQL database and get SQL database?
No, absolutely not. When I wrote this, I was just using DBA tools, because I basically wrote these demos whilst I was checking out DBA tools. So there's no actual reason for it. It was just a personal preference whilst initially writing the demos.
Gotcha. All right, great. And, no more questions are coming in. I will just steal the video one for just a second real quick.
No problem.
And just wanted to show to people as a reminder, just like I said, out in, come back here. in the email today, make sure that you're updating your modules every once in a while. And to be able to update your modules, obviously you need to install them first. Assuming that you've got them installed already, just run update module, whether that's update module SQL Server for the SQL Server module, update module reporting services tools for the reporting services tools module, which allows you to work with SSRS reports and migrate SSRS instances and deploy Power BI reports to your Power BI report server. And then if you are just wanting to know, well, what do I need to update my module at all? Make sure you're running PowerShell as an administrator like I am up above, and go ahead and add the -what if switch on there, and it will tell you, just like for me, I need to go ahead and update my module because I'm out of date, and so I'll go ahead and kick that off right now. And there you guys are. Please remember to keep them up to date. That is it. Thank you so much, Andrew, for doing this for us. I have not gotten into containers myself and needed a primer like this. And you asked pretty much all the questions I was, answered all the questions I was going to ask as you were going along. So great job there.
Thank you very much, and thank you for having me. Really enjoyed it.
All right. Thanks a lot.